Okay, good morning, good evening, good afternoon. This is Mike from Unknown Tech, and welcome to the Architect Podcast. This is episode 22, I believe. I wish I did these more regularly. Unfortunately, I've been focused on a lot of things right now, but that's okay. Matter of fact, before this podcast, I was really engaged in the new release or the latest release of the Pentagon UAP disclosure that's happening as we speak. And they just released the second tranche of information. If you guys are interested or gals are interested in this subject, you could go over to war.gov/UFO. Matter of fact, let me just bring this up because I think this is a very interesting topic. I know I'm kind of going on a tangent. This is not what this is about, this podcast, but this is something I'm extremely interested in. And uh, of course, the reason is we don't really know what the stuff is, right? I mean, we have some idea maybe of what it could be, but there's some specific evidence that they're releasing at this point in time in our history that is pretty compelling. Of course, we've seen footage from third parties and whistleblowers and these types of things, but when the government releases information regarding topics such as these, of course, they're not going to release information that they think would give us a competitive advantage or something that we know of, right? Either our technology or our adversarial technology. Um, they're not going to release the information. So the glaring thing about this information that's being released now is not only do we have an administration that's willing to do that, right? Go to bat for this, but secondly, it's information that well, it's not as compelling as I thought up to this point. There's some compelling one or two compelling items within both releases that I think you guys, gals, should look at if you're interested. And I think you'll see what I'm talking about. But the very idea of this being released shows you that we really don't know all there is to know, right, about what's in our skies out there. So I think it's a very interesting topic. And of course, again, this is one of these things that I'm very interested in. So just bear with me here as I go back to and unsure. Let me stop sharing here the chat here. So today we're going to be focused on. I put in the excuse me. I put in the subject of today's session. It was about the top three barriers or concerns or problems that enterprise customers are facing, and I would say most customers are facing because I'm hearing this, not just what I'm hearing from customers themselves, right? Because of course I view a small percentage of customers. The analysts have a much larger view of this, right? Because they have a much larger sample size than I do. But also what I'm hearing from even the frontier SaaS providers, cloud providers, reporting, et cetera. There's basically three core things that are happening out in the enterprise space when it comes to AI. The first problem really stems around the cost of tokenization. Okay, so in the past, you heard me talk about tokens. If you're on this podcast now, or if you listened to my past, or you know AI, you know what I'm talking about. Okay, so for those that don't, what tokens are is your intelligence output, right? Your input output of intelligence. Okay, and what's happening is uh, providers, neo cloud providers, SaaS cloud providers, frontier model providers, AI service providers, Anthropic, OpenAI, and now Microsoft, right, with GitHub Copilot, things like that, right? They are now charging by token utilization. Okay, and then of course you have the backend API connectivity to those. So not just the front end services, right, where you have plugins into Visual Studio Code, right? um, those things, right? Or individual tooling like Codex or Claude Code, etc. What I'm talking about is also, for the most part, AI applications or AI data, right? Required for inferencing or embedding or those types of functions, are connecting back to the back ends of these service providers over API. And so when you do that, they charge you a per token cost. Okay. And that per token cost is increasing. Okay. So, and by the way, there's this argument that's happening I'm seeing on LinkedIn. Not really an argument, but there's definitely some different schools of thought on where we are in the space of AI as far as the monetization of these tokens. And if you look at what's happening, there's two arguments. There's one that these providers are they're still subsidizing a lot of the token costs, and then the counter argument to that is, well, we're now at that inflection point where these providers are now gaining revenue, right, real revenue on the services they're providing, and I'm to the latter. All the reports are showing that now that we've hit this inflection point, that the providers like Anthropic, OpenAI, Microsoft, etc., they're now going to increase costs over time, right? To address the real costs internally and to address the percentage in revenue that they want to get out of it. Okay, and so now you're starting to see that these providers are now becoming revenue positive. Okay, from that perspective, and so it's like anything else, right? When a new technology comes out, they bring you in. Okay. And this is the playbook that's been around for a long time. This should not be new to anybody. Like, this should not be a surprise to anybody. Okay. When new technology comes out, you want to get the most traction around utilization of said technology. Therefore, when you have that traction, you have a customer base that's loyal. Some of us call it lock-in, some of us call it loyalty, etc. And by doing that loyalty lock-in, now you start paying the penalty, right? We increase prices over time. And then, there's legitimate reasons why that's happening. Okay. Certainly. They are businesses after all. And I think, when you look at it from that standpoint, you kind of understand the mentality behind it. Okay. The second thing around token economics is that there's a tremendous amount of waste, tremendous, and inefficiency. Okay, so on one end, you have the providers, right, raising their prices on per tokens, right? Or what they're doing is they're lessening the amount of available tokens per plan. Okay, same thing as raising costs, right? Don't let it fool you. Of course, it's just a different way of raising costs. Okay, and on the other side of that, you have tremendous waste due to inefficiencies in inferencing. Okay, and those inefficiencies stem around many different things. Okay, and really it has to do with a lot of it has to do with context, KV cache, etc. Okay, and what's happening is every turn at a request, that complete context is having to be loaded into GPUs again, and because of that, right, there's the waste. I'm talking about the inefficiency of that. Okay, and so that's part of it, but there's also other methods to deliver more efficiencies. I wrote about that in my blog on unknowntech.io that you guys can go and read about. So I'm not going to get into the details of that because I want to really focus on one of the key aspects today, and that's AI data readiness. So that's really what's happening. That's really the problems that people are facing right now with AI. Huge problem, by the way, massive problem, because as enterprises ramp up use cases and they ramp up especially agentic use cases, agents require much more inference, right, than chatbots do, than AI powered search does. Okay, because now you're looking at all these different things, all these multiple models being used to do many different tasks, right, etc. Okay. I did watch an AMD session actually the other day on LM cache as a method of offloading cache and doing basically bit streaming cache. Okay, so I won't get into, you go on YouTube, you can look for AMD Developer Day, I think. And they had a gentleman on there speaking around the KV cache optimization and LM cache kind of becoming this new standard that's creeping up as far as cache optimization when it comes to memory utilization, et cetera. Because that's really where the cost comes in. Okay. So that's one problem. The second problem is around security. And the reason why security is coming up heavily is because customers are wanting to get into the age of agents. Okay. They want to be able to implement more autonomy into their environment. Okay. And agents, right, are going to need to do many different things and connect to many different systems and data. And so enterprises are going to not want, but require end-to-end control and visibility for those agents. Okay. And we're not quite there yet. Now, people could argue and say there is, hang on, let me just look here, see if there's anything popping up. People can argue and say that there are tools and services that provide end-to-end, right? Or there are platforms that deliver agents that can give you end-to-end. And I would say yes and no. And the reason I say it is because I want to go back to what I talked about. Another thing I talked about in my article is around this hybridization of AI. Okay, the ability to run AI where it makes sense. It's the same thing with applications, right? You have some applications that make sense to run in the cloud, some applications that make sense to run on-prem in a data center, some applications make more sense to run at the edge. The same applies for AI. So we're not inventing new ways of delivering services and technology. Okay. The placement, right, decisions, frankly, are very similar. Meaning, where's my data? Do I require low latency? Does it make sense to move the application or not? Right? Am I going to take advantage of the application if it's running in the cloud versus running in my core data center or running at the edge? Or does it need to be a mix of those? And this is where I'm more leaning towards the latter. It's going to be a mix of those, right? So, for example, I think the best example of this is self-driving vehicles, because there's intelligence that happens in real time at the vehicle, in the vehicle. So there's computers, inferencing that's happening in real time, et cetera, in the vehicle. Okay? Because it needs to make real-time decisions, or else what's going to happen? You're going to have accidents, right? You can't wait for analytics. You can't wait for machine learning to go through. Oh, do I make a left here? There's a person walking in front of my car. Do I need to send it back, go through a machine learning algorithm, and then determine the decision? You can't do that. It's got to be immediate. Okay, so compute at the vehicle is required. But how the vehicle drives, how efficient it is, all of those things, right, they don't need low latent, they don't need things to happen right then, real-time processing, right? So they can be done in a more of a machine learning algorithm in the back end. So the data is uploaded into the cloud or the data center, and those machine learning algorithms, right? The AI side is crunching those with different algorithms, right? Same applies for inferencing when it comes to like batching and those things, right? Batching doesn't require real-time feedback or quick feedback or low latent feedback, right? Just like agents do. So if you want to do batch processing or batching, you can certainly take advantage of not doing real-time things, doing doing inferencing in batches where it makes sense. Okay. Let me go back to the security though. Agents require end-to-end visibility and control. So you need to be able to trace every action the agent takes. You need to be able to see what actions it took, how it accessed the data or the system, what tools it used, the reasoning behind it. Okay. And again, I already talked about the economics of it, right? You still need to understand the economics, like how much is being used, right? From a tokenization perspective. That's more of an economics thing or an efficiency thing. What I'm talking about is the visibility end to end. And so what that's going to require is basically partnerships. It goes back to this, like, if you're good at one or two things, really focus on those one or two things and then partner on the other things. I think that's extremely important with any system or solution provider. Like, I work at Nutanix, right? So we don't do, we have some security services, we have security solutions, but we don't do everything in the security space, right? And so therefore we have to partner with very good partners like Palo Alto, like Cisco, to enhance that, right? That security posture. So if you look at partnerships, things like Palo Alto Prisma Errors as an example for AI, Cisco's AI defense, right? Just a few examples of where you could have integrated partnerships and tooling. There's open source tools out there that you can integrate, right? There are service tools that you can integrate. So again, this I think is going to be a very daunting task for enterprises, and it's going to require very strong partnerships and a full understanding of what the customers are attempting to do. All right. So it's not just, okay, I want to deliver an agentic solution that does X and solves for X. It's intimately familiar on how it does X and how it solves X. Because if I understand that, then I can interject the tooling. And I don't mean the agentic tools. I'm talking about the security tooling, the visibility, the tracing, the observability stack, all of that to understand and monitor those agents in real time. And you need to have gates, right? You need the ability to stop things from happening. If it goes off the rail, right? Something's missed, right? And so those things need to be gated. And so therefore, I think I wrote, you may have seen the LinkedIn post I did the other day. I talked about SpaceX's motto is basically test it like you drive it, or drive it like you own it, or test it like you would own it, right? Or you're meaning put it through its paces like it's in production. That's extremely important. 100% important, especially when it comes to agentic autonomy. Okay. So I'm not going to focus on that. Those two things I'm going to talk about in later episodes. The third thing is what I'm going to focus on today, and that is the stuff that really no one wants to really dig in on. And that's AI data readiness. It's not sexy, it's not fun. Okay, it's probably fun for data scientists and data analysts, right? That's their job. But when you look at value, right? I wanted to talk about the value equation for a minute. We can all agree that the core foundational data in our business is typically structured data, and a mix of structured, unstructured, and semi-structured data. A lot of it's structured, right, in databases, and so we can call them the crown jewels of data within your environment. But the value is not seen there. The value is seen at the interface, at the UI, at the consumption layer, okay, to your customer, I mean. And so that's why I say it's not sexy, right? I think we need to kind of turn this around, the messaging around when it comes to data and AI data readiness. Databricks did this very well. You probably saw the post I put on LinkedIn about that. If you didn't, you can look on LinkedIn. And how I look at Databricks as just in the cloud, right? Because it's a cloud solution. It's a in the cloud solution. It's just a complete understanding of data and data services. Notice I didn't say storage. I'll talk about that in a minute because those two different things. Talk about data services. And so, right? So now basically the inventor of data lakehouse, right? Data warehouse, data lakes coming together, structured, unstructured, semi-structured data. And then on top of that, bringing AI to the data. This with Mosaic, that was genius. That was genius. Okay. The ability to move AI to the data. Okay. The data's already there. It's in the lakehouse, right? You're curating it. You're getting it ready. I'm going to talk about data curation. I'm going to talk about some of the tooling. Matter of fact, I actually built a NVIDIA pipeline through a blueprint using NIMS and NEMO on my DGX Spark. I'll walk through that process with you guys in a few minutes. I think there are simpler ways to do it though, and I think that you may have heard me mention Nutanix AI Data Hub. We'll talk about that too, and how we're bringing AI to data in a different way. Okay, and so let's just talk about what I'm going to review today. I'm going to share my screen really quick here. Oh, before I go, if you guys want to watch YouTube, that's the link for today. All right, YouTube tends to have better quality than LinkedIn. You can go to the YouTube link here. Even if you don't watch me live, you can go to this YouTube link afterwards and you can watch the video there. Again, I tend to believe that YouTube has better quality, better codecs than LinkedIn. And you can also interact with me on YouTube as well. So let's go to the demo. I'm going to share my screen. And I'm going to just bring this up really quick. So hang on one second here. Share entire screen. Okay. So this is basically a diagram of what I built on the DGX Spark. And I'm going to walk through this here a little bit. So essentially what we have here is our data sources. Okay. And in this demo, we're really going to focus on unstructured data. In a future demo, we're going to talk a little bit about structured data and how we can do that on-prem as well. But this is really around unstructured data, right? So, oh, I'm sorry. Let me remove the thickness of that, get rid of this, go back to this. Really, it's around this box here, okay? So in your environments, right, you will have this data probably spread everywhere, right? You'll have file shares, NFS shares, object storage, etc. In my case, in this demo, I have a NFS share on my NAS, okay? And essentially what I've done here is and this is just my NAS here, my NAS interface. We'll go to files. Oh, I have to log in again. I'll go to files and shared folder, and you can see here I have this folder called K3S, and it's using NFS, okay? And it's on volume 1 K3S, okay? So this essentially has, using the NFS CSI provisioner in Kubernetes, this is mounted into the DGX Spark. I'm going to talk about how the DGX Spark is configured. Most of the time, I'm looking at things like people using DGX Spark. They're just using Docker, right? Or just using the NVIDIA Container Manager or these different tools. I actually installed K3S, the ARM variant, on my DGX Spark because fundamentally, even in DGX or HGX, right, you're going to have a Kubernetes layer. Even in a HGX platform, even in could be a Dell 9000 series, right? I can't remember the actual term, or an HPE platform that has, add in, GPUs, et cetera. It doesn't have to be SXM. Could be add in GPUs. You're fundamentally going to have Kubernetes as the orchestration layer underneath. Spark doesn't have that out of the box. So we have to build that. We have to build that orchestration layer. So I've done that already with K3S. Now, I'm not going to go over how I did that. that's something fairly simple. And by the way, if you're doing anything in AI as an infrastructure or platform engineer, you you really should know your way around Kubernetes. Okay, because like I said, Kubernetes is the orchestration layer. It handles all of the scheduling. Okay, all the GPU scheduling, all the orchestration of inference, all the orchestration of endpoints. More than likely, all of your AI applications will be running in Kubernetes. It's not going to be running in VMs. More than likely, they're going to be running in Kubernetes. Okay, all of your pipeline creation, all of that will be managed through Kubernetes. And I'm going to show you what that looks like a little bit, but I'm not going to show you the entire Kubernetes stack. Again, it's a single node. It's one DGX Spark, right? I would love to have 3 DGX Spark, but if, now they're $4,500. I think I told you I paid $3,200 for mine. Now they're so wildly overpriced because of memory shortage, et cetera. Now you're looking at, almost $15,000 for 3 of them to have a real Kubernetes cluster, right? I have a single node K3s installed on the Ubuntu image. Okay. NVIDIA GPU operator. I have time slicing configured, all of that on the GB10, right? To share the GPU out, etc. All of that. And so just think about that as the foundation. Okay. So again, this is the K3s. Within the K3s, I have my model directory, right? This is for Ollama. I didn't use Ollama in this case. All right. I use NIM and I use VLLM, and I'll show you why in a few minutes. A lot of it has to do with ARM. So I will say that something I'm a little troubled about, to be honest with you, is the ability to use all of the NVIDIA tooling on ARM-based platforms. Because remember, you have Grace Blackwell platforms, right? You have Vera Rubin that's coming. Okay. Well, Grace is ARM-based. Vera CPU is ARM-based, right? And a lot of these models aren't even ready for ARM yet. So at the most expensive solutions that NVIDIA provides, GB300s, right? And the new GB300 with the tensor offload, right? NPUs, whatever you want to call them. Some of the stuff doesn't work as expected. Some of the NIM models, right? So again, that's something I'm going to have to dig deeper a little bit in. But I couldn't get for example, I couldn't get one of the models working. I had to use with NIM. I had to use VLLM to get it working. So it's a mixture of for inference, VLM and NIM, and I'll get to that in a minute. So let's go back to the shared folder under K3s. We're talking about data. So within this folder, I have basically 3 pieces of unstructured data. I guess you could say Excel is structured, but basically 3 pieces of unstructured data. I have, and by the way, this demo is really around a customer service agent, okay, that is using data through agentic RAG, okay, to go through a return of an item process. Okay. And I have a fake company. It's ServerCo. It basically is a enterprise data center infrastructure retailer. Okay. And so I just want to kind of show a quick demo of how this would looks like, but I really want you to focus on the data pipeline side of it, not so much the agent demo. All right. Let's focus on the data pipeline side of this, because this is what's extremely important at customers. And what we're seeing is 60% of failed AI projects are due to data and AI data readiness. 60%. So if we can solve for that, right, then we can move on to the other challenges I was talking about around inference and agentic AI security. Okay, so token optimization, token economics, and agentic security. You have to get the data right first, though, right? Because we're feeding your data into AI. Models don't know about your data. I don't care if you could sit here and say that DeepSeek and Qwen or whatever are the best models out there. It doesn't mean jack to you if it can't interact with your data. Okay? And so I don't say they're stupid, but they're stupid when it comes to your data because they have no idea about your data. And so how do you get your data AI ready? You have to go through a pipeline. You have to go through a curation process, all of that. And so we'll talk about that. So again, my demo basically is an agent which is going to access an agentic RAG customer service agent to go through some of this company's data. I have the RMA exception process in a Word document. Okay. I have the return policy in a PDF, and I have the customer orders and the customer information in a spreadsheet. Okay. An Excel spreadsheet. And so what I've done is I've built this pipeline, okay, using a few tools. Okay. So one tool is called NVIDIA NV Ingest. It's not NV Ingest anymore. It's Nemo Retriever. It's called now. So you may understand it now as Nemo Retriever and not NV Ingest. Okay. Well, this is basically a container running in Kubernetes. Okay, and it allows me to do a lot of things. Right, allows me to curate the data, extract, chunk, embed into a vector store. In my case, I have Milvus, and I'll show you guys all this here in. Let me just make this bigger here so you guys can see it. Okay, so let me see kconfig current context export kconfig get context. Okay, so I need to use the default context here. Morpheus is my NKP cluster that's in my Nutanix environment, Kubernetes NKP environment. This default is the K3s cluster on my DGX Spark. All right, so if I do kget nodes, if I do k, and by the way, k is an alias for kubectl, kget nodes wide, right? I'm running on my Spark. It's control plane that's schedulable, right, for workloads, not just control plane function. Okay, it's using version 1.35 K3s1, right, and it's on the Ubuntu 24.04.4, which is the image for the DGX Spark. This is the kernel version, right? Because it is a DGX Spark. It's basically using DGX or a version of DGX OS for Ubuntu. And I'm using a container D as my CRI. All right. Okay. So this is what's, this is basically my single Kubernetes cluster. So if I go in here and I do a get pods on the CS pipeline, okay, you'll see that I have a bunch of pods running here. I have Milvus running, okay, which is my basically contains, it's basically a Milvus stack. It's basically the vector database, okay, the MinIO S3 object storage, all right, together. All right, so if you look at this diagram again, right, this vector storage, right, to the right is basically the Milvus stack, okay, which I said contains MinIO for the S3 objects, etc. So what happens is I run this process, okay, and what manages this is KubeRay. So I want to make sure I point this out. So there is a process, right, that's more CPU bound that KubeRay will handle, and there's a process that's more GPU bound, like the embedding process, the curation, all of that. That's more GPU bound. Okay, so if I go back to the image here, you have the curation, which happens first. Okay, so basically, what will happen is as the job kicks off, and it already kicked off, a pod will spin up, right? Basically, it's a job, and that will be. Let me see if I can see. Okay, get jobs. CS pipeline. Wow, I can't even spell. It's not. It won't. What will happen is basically a job will kick off called Nemo Curator, and that'll curate the data for me. So I'm using the Nemo Curator, which is part of the NVIDIA stack, to curate the data. Now, this is going to get a little complex when I walk through this a little bit, okay? So in my repository here, right, I basically have an ingest Python, right? I have a curator job that runs, and this curator job essentially looks for PII, right? And you can see here, it looks for PII, and it looks for, the name, email address, phone number, location. And what it does is it will modify or input a modification. Or, for example, in the email address field, in my case, instead of showing the email address after the curation happens, it shows just email. Okay, and I'll show you what that looks like. So when that curation job is done, okay, and I go into my folder, I'm sorry, I'm all over the place. I go into my NAS, there is a folder that's created called curated. This is after the job is done. So let me show you what that looks like. So if I go in here, these are the curated documents now and a JSON report, right, around the curation that happened to the documents. Okay. So let's look at the differences between the customer data spreadsheet, which contains the orders, right, and the non-curated, the original, which you can see here has the full email address and phone number, and then post curation, right, it put email in and it put these numbers in. So essentially, I'm stripping out the PII information off of that. So before this information even goes through its parsing, its chunking, and embedding process into the Milvus vector database, it has to be curated first. Okay. And you can see how complex this can be, this process. Now, let me take that back. The process is not complex, but the delivery of the coding, right? The building of the curation job, right, can be very complex. You have to have Python skills. You need to have developer skills, coding skills, and need to understand data curation. Now, I'm not saying that enterprises don't have these skills. A lot of them have these skills. A lot of them don't. Okay. Or a lot of them spend a lot of time here, or they don't spend enough time here. That's why 60% of AI projects fail due to data readiness. Okay. Because they're not spending enough time here. So the question is, how do we make this process easier? And I'm going to come back to that a little bit later. Okay. The next part of this, so I want you to table that. How do we make this curation process easier? Now, I want to go back to the ingest process, right? You can see here, this is the pipeline ingest, right? It's curated, right? Then it's chunked and embedded in the Milvus database. That's the pipeline. Get your data curated, ready, right? Then bring it into the vectorization process. All right. That way it's ready and the agent has access to the data it needs without exposing, right, PII information. Matter of fact, that's like a NIC card, right? What I meant to say is PII. So without exposing important information or customer information that's sensitive. Okay. That's the whole process. And like I said to you, it goes through that process. It goes through the OCR parsing process, right? And it goes through the chunking, and then it gets embedded into a vector store. So it takes this and goes right through this process, right? All the way through to the vector store. When it's vectorized, the data is ready for the agent to be able to access the data. Okay. And I mean agent, I mean an agent is obviously not just something that does actions on your behalf, but it also has intelligence. That intelligence obviously is the model behind it. Okay. I want to just talk about the compute layer, however. Okay, so this compute layer is done by a open source tool we call KubeRay. Okay, this does all the scheduling. Okay, so if you go back into my Kubernetes cluster, you can see here I have a pipeline head. Okay, and this pipeline head is basically a KubeRay worker, and it basically, or excuse me, KubeRay management node, and it basically spins up workers as needed as it goes through the pipeline process. Okay, that's the beauty of combining Nemo Retriever with KubeRay. You have the orchestration layer in KubeRay, and you have the NeMo retriever actually managing the pipeline process. Okay. And it's extremely important when these two work in tandem. It's very, very powerful. Okay. And that's what that does. Then you have the GPUs, right? The Kubernetes operator, of course, right? That's plugged into the GPU alignment. Does auto scaling via Kubernetes, right? Auto scaling. Again, goes back to what I talked about with the importance of Kubernetes, the ability to scale, ability to stand up jobs, right? Automatically, scale up and down automatically, right? That's the important part of the data pipeline. Imagine you're doing this for millions of unstructured images or billions, right? Or you're batching this and it's massive. I'm only doing 3, right? I'm just doing 3 because I had an example. I created some data as an example to show you what the process looks like. But imagine doing this at enterprise scale is what I'm talking about. That's the value of Kubernetes and NeMo Retriever. Okay, working together. Then now you have your AI application layer over to the right, and now this AI application has access, right, to connect to the vector store, right, if needed, to get the relevant data out of this. Okay. What I mean by relevant data, your data, business intelligence is what I call it. Where is your business intelligence located and how can your agent access that? Okay. So again, notice I didn't talk about storage so much. I talked about the pipeline. Now, the storage is important. Okay. It happens that my NAS is all flash, it's all M.2 NVMe. So it's very, very fast. That storage for the ingest side is extremely important. It gets more important when it comes to billions of images or billions of HTML files or billions of PowerPoint files or Word or PDFs or a mixture of those, right? Extremely important. Compute side, right? Because it's a combination of CPU, GPU, and storage and networking that allows for this to happen. Notice I didn't move the data though, did I? Notice the data stayed exactly where it is. The curate data is still on the NAS, okay? But we're using a vector store, right? Obviously, as the access, right? As the ability to come up with correlation between multiple, different pieces of information within these documents, right? We're vectorizing the data, right? We're assigning numerical value to the data in the databases, in the vector database, so that the agent can look at that and reason about that to get the right information about back. That's the important piece of this. I'm going to talk about a little bit about how this process can be easier or become easier. Like I said, table that for now. So I want to go back and talk about, okay, what handles the inference side. So I do kget pods namespace cs inference. Oh, did I spell that right? Inference. Oh, okay. And so I want you to not pay attention to ASR or TTS. So my goal was to have the agent be able to interact with the agent through voice. The agent will be able to talk back to you in voice, in voice. I have not got that working yet, but you can text with it and it'll chat back to you. Okay. And we'll go through that. So I want to focus on these two models. So I do have, and even though the embedding says NIM, I believe this is running in VLLM because the embedding NIM from NVIDIA didn't natively support GB10 or ARM. Okay, so I'd use VLLM. And then I'm using Qwen, I believe 3.6, 35B, I think. Very, very good model for agentic workflows. There's better models for this use case. For coding, though, I don't think there's a better model for that size. It even beats like GPT OSS 120B in coding. A 35 billion parameter model beating GPT OSS 120 billion parameter model in coding tasks, right? So if you're doing like anything with coding or anything like that, I would look at that Qwen 35B. But it's also a pretty good agentic reasoning model. There are better though. Gemma, 4 probably is a better model when it comes to this. I could have used that too. But again, I'm bound by the memory limitations within the DGX Spark, which is only 128 gigabytes of unified memory. Let me see if I can connect. I had a little problem connecting with this morning. Yeah, I have to go look and see what's happening. But in my dashboard, I'm using 120 gigabytes of my VRAM or my unified memory out of that 128 gigabytes because I'm using all these models. All these models are running, and plus all of the other things are running on this. Okay. Then you have the application. Is it agent? Right? Application front end and back end. It's basically a Node.js application. Okay. And I also built a dashboard around the curation process. And so when we go to that, right, when I go to csagent.local, which is the URL, you have the chat, where you can chat with the image or the agent, and you have the pipeline monitor. And so you can see here, it went through the pipeline, right, of the NFS source, it curated the data, ingested the data, chunked it, embedded it into the Milvus vector database. It told me I found 12 entities, right? How many entities were masked? Okay, remember, you saw the masking that was happening between the spreadsheets, right? You had the pre-curated data spreadsheet, and you had the post-curated data spreadsheet, which I showed you the masking, right? And you can see here, phone numbers were masked, email addresses were masked. There was no SSN or I don't know what person is, but that wasn't masked. I will say that there is credit card information in that spreadsheet. I didn't add that to the curation pipeline. I probably should have done that. That's one of those things that definitely you want to mask, right? Is the credit card information, the credit card number. It created 3 vectors out of the customer records, 1 vector out of the return policy, 1 vector out of the RMA exceptions. And the reason that is because they're very small documents. So people are like, 1 vector, well, shouldn't you have a bunch of different vectors out of that? If I had a massive document or a much larger document, I think it's only like 1. The return policy is like 1 little paragraph. The RMA exception is like 1 little paragraph, right? And so it didn't vectorize. And then, of course, it manages the readiness of my inference endpoints as well. And it says all NIM. That's not accurate. The embedding model, this NV embed QA model, is actually running in VLLM. Okay. So VLM on Kubernetes, NIM on Kubernetes, not NIM running just Docker, right? Because I also have a full observability stack stood up on here. I have basically the Grafana, Loki, Prometheus stack, GLP stack that's also running on here, so I can get not full observability. I don't have tracing stood up, but I get some observability on the environment. Okay. And so that's also important as well, right? To be able to visualize, monitor. I should be using OTel a little bit on this too. I haven't implemented that, but that's something that, again, I'm at the max limitation of CPU on this node. Remember, it's not virtualized, right? I have 10 CPUs, 10 cores to work with on the Grace GB10. Okay. And I don't have any cores left. I don't even have anything left to add that I can add from a core perspective. Add any additional pods. I can't do it. So I can't add OTel. I take that back. I don't even have Loki installed. I couldn't even do Loki. I have just basically Grafana and Prometheus. Okay. So I don't even have a logging mechanism or a logging aggregator to aggregate the logs and visualize it in Grafana, right? Which sucks. That means I have to go through a bunch of logs within Kubernetes, right? Which, as you know, can be very daunting. Okay. So if we go through the chat window, what I want to do is kind of walk through this process a little bit to show you how this works. And I kind of outline this. Let me see here. So I had the documentation here. I haven't uploaded this to GitHub yet. I will do that, and I'll link it into the video description. But essentially, I do have a walkthrough of this too here. Just hang on one second here. Let me just find it. So this was one of the observability pieces I wanted to document. Things you could add later, right? If you wanted to add OTel or Langfuse, right, or NIM metrics, you can do that. If you have a system that has, more, um, uh, infrastructure, right? More availability as far as infrastructure, processor, etc. This is the full chain, right? Looks at the NFS. I'm using pandas to read the XLS document. It goes through a curation process, right, of email and phone, right? Does the replacement, right, or the masking of those two things, those two fields, which it did. I showed you that. It goes through a parsing piece of it, creates chunks, embeds into Milvus, right, and then Milvus does its thing, right? Does Cosine comparison, etc. And then our agent tools, right, are the Qwen 3.635B. Yep, that's what's using. Qwen 3.6, 35B, A3B as its model, the agent's model. Okay, bear with me a second. There were some changes I had to make. Some things weren't working. So I had Claude Code help me with that. I love Claude Code. I really do. I love it. I was having it actually help me go through the troubleshooting around the voice piece of it. And I didn't go any further into it because it wasn't really important. Matter of fact, I shouldn't even included it. I just thought it'd be cool to have, I guess. And that's, again, it goes back to like, is it cool? If you're looking at what's cool, you're wasting time and you're wasting resources, right? That's not what it's about. It's about functionality and value, right? That's really what you're trying to get to. And I'm a big believer in keeping it as simple as possible. Oh, hang on. So I go through this. Where the heck is it? I may have passed it. Let me just go through it and see. Let me just go through this process. So here's the agent, right? His name's Emerson, service customer agent, right? Not going to help you today. I'm having an issue with my PCIe riser car riser. Let's see what Emerson comes back with. Oh boy. Is Emerson not going to respond? Are we having an issue? Or are we having... Here we go. Sorry to hear you're experiencing issues with your PCI riser. To get started, can you please provide your ASI account ID? So the ASI account ID is this right here. I'm going to choose this one. What else so I can verify your account? Once I have that, I also need to know when you purchased it and the exact product SKU. 2 weeks ago. Purchased 2 weeks ago. And the SKU is... Hopefully it's a little bit faster. It's a little slow. I mean, again, this is running on DGX Spark. Not the fastest from an inferencing perspective. The memory bandwidth is not great, right? It's got the compute of a 5070 Ti, basically, from a Tensor Core compute, video, GPU compute perspective, but nowhere near the bandwidth of a 5070 Ti. All right, I want to say it's only like 300. I can't remember what it was, but it's very, very limited memory bandwidth. So it's slow. The good news is that it does things, right. It allows you to kind of still get through basic things, right. That's the whole point of it. It's not there for. I hear people say, "Oh, DGX Spark edge inference." No, no, not really. I would I would say I would not put this in production at anything, right? From an inferencing, I just wouldn't. A developer, right? Someone who's learning, who uses it to learn, like me, 100% perfect, right? So you can see here he did all these lookups, right? And these lookups, or I shouldn't say he, but it, the agent did all these lookups, and the lookups are going against the vector database. Okay. Now it did have a problem with this. I'm not sure why I had to look, but essentially it understood that it did read the exceptions, the return policy, and did a customer looked up, and basically I've confirmed that your return is as well within our standard 30-day window. Can you provide a brief description of malfunction you're experiencing with the card? Example is not detected on the system. It's not detected. And what'll happen is the agent should automatically create the RMA for me based on my information, give me an RMA number, right? And then, it'll send me information as far as where to mail back the product. Okay. And so this is just like, a quick example of a support agent or a customer agent where you can actually implement in your environment. And I know this is a very simple demo, but I want you to think about giving this agent more autonomy to your data, being able to answer questions, having access to additional data, giving it guardrails, of course, around how you operate and your compliance and your regulatory guardrails, right? That you want to put in your safety guardrails. And I just really feel like customer service, and a lot of people are not going to, are going to hate me for saying this, but customer service to me is like the table stakes first job that you guys could kind of replace. And you're not really trying to replace jobs, of course. You're trying to basically, see where you can provide efficiency in your business. And to be honest, I think customer service is probably the first level of agentic interaction you can implement, right? Now, you may look at this and say, well, this is just a chat bot. What I would say is you could make this more of an agent to do more things. So, for example, what if I had to do some processing? What happens if they sent me I send information back into the agent and the agent processes the claim or something like right there in front of me? Maybe I'm insurance as an example. I submit a claim. I get on and say, "Hey, I want to get a status on this claim." The agent has access to your claim, gets back to you and says, "Oh, you missed XYZ in the form, or we need this information," right? And then sends it back or sends it to a different place or gives you more intelligent, information based on the claim, or processes the claim, gives you all the information back on what to expect from a timeline, et cetera. Just having access to a lot more information. So you can see here, I confirm that your account is good standing. Your purchase falls on a standard return. Could you please provide your original order number for the PCI riser? If you don't have available, I can reference account ID to create the RMA ticket. Reference account number to create the ticket. Okay. So again, continuing to look at the vector database, I want to show you that and these little keys and checkboxes, because it's looking in that data to make sure it can give you the most appropriate response. So what do we do? I mean, I basically showed you on basically a DGX Spark, the data pipeline. Okay. The technology I'm using to do that. And I want to just focus on that for now. So one of the things I talked about was bringing AI to data, which we did a bit here. But I think there's like so much more opportunity to simplify this process. Like what if you saw that I had to build these things in a programmatic way, right? With Python. So like the curator job, right? But what if I could build a curation or build a pipeline with natural language? What if I went in, what if I had a interface, right? That I could interface with this. Let me just erase some of this and show you what I'm talking about. What if there was a layer above this, okay, that actually sat like this, okay, and had direct access into this process that was very similar to this. So if I do this, what I mean by this, what if I could do this through natural language? So if I cut this out, I copy this, and I put this up here. Oh. And this process allows me to actually interface with the pipeline. So now I'm actually using generative AI, right? I'm using generative AI to say, curate this data, leave out X, right? Mask X, take out the any PII like SSNs or emails or payment information, right? And then go through, right, the curation process. Okay. What if I could do that? This is what I'm talking about with bringing AI to data. The ability to make this entire process simpler. And this is where Nutanix will be playing when it comes to data and data pipelines. We'll be combining Nutanix Enterprise AI capability, right? And aligning that to the data pipeline perspective and data service perspective. Okay. And what I mean by that is think about it as a data hub and then being able to align Nutanix Enterprise AI inferencing against the data side of it. So using data, using AI, and this is a funny thing, and you're hearing this a lot, by the way, using AI to actually get your data ready for AI. It's the same thing as using AI to build better products, AI products, or better AI features. Very, very similar to that. Okay. So this is what I'm talking about when it comes to the data pipeline perspective. This is where you need to put more focus, right? This is where Nutanix will be providing a lot more value when it comes to the AI data hub. You're going to see that in the future. That's more of a roadmap item. Okay. But in the next one, what I'm going to do is I'm actually going to show you guys some things around, you can see here the RMA was created, some things around the other two areas. I want to focus on token efficiency, token economics. That's going to be the next episode. And then after that, I'm going to talk about security, observability, et cetera, when it comes to agentic AI. So again, I hope you have a great day. I hope this was meaningful information. And hopefully you can take this back with you. But I would just say, if you're in the enterprise space, right, if you're in the solution provider space, you really need to get your customers thinking, or you should be thinking about prepping or getting your data AI ready. Because if you don't get it ready, it's going to be the same thing as the garbage in, garbage out problem, right? If you're sending your data in, could be insecure, could be not the right data, right? Your agent's looking up data on things that don't matter, or it's just a bunch of garbage it has to get through. You want to make this whole process much more efficient. Okay. It's going to save you time, money. It's going to get you better intelligence, right? Better output, better response, right? Ultimately, a better experience overall. So I hope this, like I said, I hope this was meaningful for you today. I know I'm asking a lot for you guys to actually wake up and on Saturday and listen to me talk about AI stuff. But I think it's important, and I hope you enjoyed today's session. I look forward to talking to you guys in the next one. I hope for those in the U.S., you have a great Memorial Day weekend. If you have family that's in the military or doing service, or a firefighter or a policeman or somebody doing service, right? Please give them a chance to thank them today. I want you to take some time with your family, but also reflect on the sacrifices that the great people of this country have made for us, so that we can live in a free society, a free country, and we could do things like podcasts and things openly and expressively. So again, hope you have a great rest of your weekend and a very productive week ahead. Thanks.